Alejandro and Veronica, did you guys check your test corrections against my answer key? Do that too. Arlene has the answer key. Okay, so you guys were just for the people who are joining us on the video right now, I'm giving 2 level 1 problems. That's with the answers. This is just to assess where you're at. Level 2, here are 2 level 2 problems because there is a coefficient in front of the x squared. Oh, it's my copy. Okay, how many of you guys are familiar or normally use the box method? Raise your hand if you normally use the box method. 1, 2, 3, 4, 5, 6, 7. What the box method is for what? When do we need the box method? When there's a number in front of the x other than 1, right? Okay, good. Do we have enough time to work on this problem? Yeah. Yes, I think so. Oh, I can't stop. Oh, no. Oh, thank you. Okay, so let's look at this. There's a coefficient. So there was a video where this guy called it the rainy day method. These are nice because there's no coefficient or other than 1 in front of the x. But when there's a number here, oh, it makes me sad. It's a rainy day. So what do? I bring out the umbrella, okay? So this is what he does. He does the x method. So the 10x is here, and then the 3 times 3 is 9. So you think, what are the factors of 9, 2 numbers that multiply to 9 but add up to 10? 3 and 3 do not add up to 10, but 9 and 1 add up to 10, right? So some of you guys might like to use the box method. I realize that I used to love it, but I don't like it as much as I used to, and I'll tell you why in a minute. But if you want to use the box method, okay, you know, area model, all of these boxes should add up to this. So we have 3x squared, we have 3, and we have to make 10x, but we're splitting that 10x into what? 9x and 1x, okay? 9x plus 1x equals 10x. So really all of this is here, right? Yeah. Now let's factor out. What's the area of this box? 3x squared. And the area of this box is x. So what do you think is the length of this rectangle? They both have what in common? An x. Okay, x has to multiply by what to make 3x squared? 3x, because 3x times x is 3x squared. What times x will give me 1x? 1. To find the area of this box is 3x times what? 3. You see that? 3 times 3x gives you 9x. And then 3 times 1 is 3. So that tells me that if this side is 3x plus 1, and this side is x plus 3, the area of the whole thing will be 3x squared plus 1x plus 9x plus 3, which gives you that. So that tells me that 3x plus this factors to 3x plus 1, quantity times x plus 3. Okay? Is there a question about how I use the box method? Now technically, yes? Okay, so you're looking for the greatest common factor. That's a good question. How do you know what to pull out? When you look at the 3x, I'm just going to look at this line, okay? When you look at the 3x squared and 1x, oh, that just made it real dark. What is in common? They both have an x, so the greatest common factor is an x. So I pulled out an x. And then what are you left with? 3x and a 1. Okay? Now that you already have that, that limits what you're pulling out a 3x out of the 9x, so what is left? A 3. Okay? And it should all match up if you did it correctly. You guys, you know, the box method is nice. It gives you like a nice graphic organizer, but sometimes you could use it without understanding what you're doing. What you're really doing is factoring by grouping. Okay? What you're doing is you're rewriting the fact that 3x squared plus 10x plus 3, we're splitting up that 10x. It's called it's called split the middle. Split the 10x into what? 9x and 1x. The order does not matter. Do you guys agree with me that this logically is the same thing as this?
Yeah.
The only difference is that the 10x became a 9x plus 1x. But the beauty of this is that now I could group them. I have 4 terms here, but I'm going to group these together and these together. When you're adding stuff, you can group them differently, right? Like if I were to ask you to add 1 plus 2 plus 3 plus 4, I don't have to do 1 plus 2 is 3 plus 3 is 6 plus 7. I could do it like this and say 3 plus 7 and still get the same answer, right? So that's all I'm doing here. The thing is, if I have this, what can I factor out? A 3. And what will be left? A 3. Oh, yes, sorry. Okay. What can I factor out? I could factor out a 3 and an x, huh? So what's left inside here? An x plus 3. Okay, so that all came to here. Now let's go over here. Can I factor anything out? Nothing. So it's just going to be x plus 3 over here. Technically, what's invisibly in front? A 1. This is kind of like what we've been doing, you guys, in pre-calculus. Do you guys see that they're like terms here? Yeah. You see how they both have an x plus 3 here? I think a lot of you guys like to see it as factoring out. Since these two terms both have an x plus 3, can I factor out an x plus 3? Yeah. Okay, if I factor out an x plus 3, what's left here? And what's left here? See that? To me, I like that method better. It's the same thing, but I like it better because it makes sense to me that 10x could be split, and then I could group, and I could factor out. Another way to see this is, look, if I have 3, let's say this whole thing is just called star. 3x, oh, that looks too similar to the x. Let's call it dot, okay? If this whole thing was called, let's just go down here. If this is 3x times dot, smiley face, plus 1 smiley face, you kind of see how there's like terms here? In the end, how many smiley faces do I have? 3x plus 1 of them. Right? I have 3x of them here. I have 1 of them here, so I have 3x plus 1 of them. And what is them? X plus 3. I don't think it's like that. No. To me, it's combining like terms. But if you want to factor it out, that works here. That works here. Okay? Raise your hand whether you, regardless of how you did it, if you were able to get this answer on your own. 1, 2, 3, 4, 5, 6, 7. Okay. If you were able to get this problem. So some of you guys are you're good with level 2. Some of you guys need more help on level 2. Everybody, please do this problem now. The second problem, another level 2 problem. Yes. It's another rainy day. Oh, you didn't do it? I mean, you already did it? Oh, okay. Just, yeah.
Put it more quick to see how you did it.
Yeah. It's a pre-assessment.
With the names, and CC me on it with the names of the students that are here. Just
Okay.
we just want to head count and know who's on site right now.
Okay.
Thank you, everyone.
Okay, I need everyone's name. So I have Veronica Alonso, Alejandra, Robert. Woo! Josue Olorio? Osorio. Arlene Hernandez. Noel Hernandez. Lulu. Okay. All right. Are you guys ready? So what did you do first? You're thinking of two numbers that multiply to negative 14 but add up to 13, right? What would those be? That's an easy one. What? 14 and 1. Which one's negative? The 1. Okay. So I'm going to go ahead and do my grouping method because I like it. Okay. The 13x is what? You could split that up into 14x minus 1x, or plus 1x, yeah? Minus 2. Now let's group them. Like this. What can I pull out of the 7x squared plus 14x? 7x. Okay. And what's left then? X plus 2. What can I factor out of here? Negative 1. So then I get an x plus 2. You guys agree that I get an x plus 2? I factor out negative 1. So now what do I have? Let's combine like terms. We have, well, we could factor out an x plus 2, right? So what will be left? Okay. Does anybody need me to do it the box method way? Yep. Okay. So since I have 7x squared here and minus 2 there, but I'm going to split up the 13x into what? 14x and negative x, yeah? Or negative 1x. If I factor, what can I factor out of the top here? An x, right? Yeah. So then what's left here? 7x. And what's left here? A minus 1. Yeah? If I factor out an x from here, I have a negative 1 left. That's why x times a negative 1 is negative x. Now here, I already factored out a 7x, so what has to come out? What's left? Positive 2. Because it's positive 14. 7x times 2 is positive 14. X. 2 times 7x is 14x. And then 2 times negative 1 is negative 2. So what do I have? X plus 2 times 7x minus 1. Okay? Raise your hand if you got that one correct. Okay. Doing better. All right. Now let's hit the level 3. Okay, question. Do you guys want some more practice on level 2 before we move on to level 3? Okay. I'm going to give you guys a level 3 as a test to see if you're ready for it. Okay? And then I'll give you guys some worksheets.
How many levels are there?
3. Actually, before I get to level 3, I should talk to you guys about special cases.
4. Difference of cubes. Let's do it.
Difference, yeah, true. Okay, I'm going to give you guys the same problem that was on the test, which was x plus 1 to the 4th minus 4 times x plus 1 squared. Factor completely. Okay? Factor completely. Factor completely. erasers. So what if I tell you, to expand, this is not quite the right word, but if there's like a 10, 100 times 9, when I ask you to expand it, I mean obviously it's not called expanding when it's just pure like digits, but what is that asking you to do? Multiply, so that's 900. But what does it mean to factor? So take out, so okay. So this is factored, right? Expanded is like, okay, like, well, it's not really called expanding because it's numbers, but you know what I'm saying, okay? So like expanding this would be x squared plus 4x plus 4, right? But factored, this is factored. This is expanded. You get me? Okay. All right, so let's talk about this, okay? What is the first thing that you can do? Oh, can I tell you my favorite sad story? Okay. I don't know why everybody decided to do this on the test in 5th period. Okay, first of all, they expanded x plus 1 to the 4th is x plus 1 plus x plus 1. I like that. I don't mind that because that tells me you understand what that is saying. Minus 4 times that. That's great. So can you just start crossing them out? Where'd they go? They just disappeared. And so they're left with x plus 1 times x plus 1 minus 4. Where did they go? Can you guys help me understand what made people think that they can just start slashing stuff out?
Because they sound yeah, because there was a lot of them. So they were just like,
oh, there's just too many. We don't need those. Just let's get rid of them.
Yeah, because you know when you divide, you can like.
Yes, people were thinking that it was a rational expression, right? If it was x plus 1 times x plus 1 times x plus 1 times x plus 1 over negative 4 times x plus 1 times, can you start slashing them out here? Why? Why can't I just do that? Because I feel there's too many and we just gotta trim it? No, why can't we do that on a fraction? Because what's x plus 1 divided by x plus 1?
1.
Anything divided by itself is 1. And 1 could just go invisible. So we could do that. Okay? But is this the same situation as this? Tell me. Is subtracting the same thing as dividing? Tell me. No, right? So I guess what people are thinking, I'm thinking, maybe you guys can help me out. I guess people are thinking, well, the last time I saw lots of expressions multiplied together was a fraction, and I have muscle memory of just like slashing stuff out. So here's a lot of stuff too, so let me just start slashing stuff out. Is that what they were doing?
Yeah.
Happened so much, it made me want to cry. Okay? So, alright, what can I do? Can I slash them out? No, but what could I have done with them? I could have factored them out, right? That wasn't his. I could factor them out, right? So how do you guys see how there's two terms here? Do any of these terms have anything in common? They both have an x plus 1. To what power? The second power in common. Okay, so if I take out 2 powers of x plus 1, how many powers of x are left? 2. If I take out 2 powers of x plus 1 from here, what's left?
-4.
Minus 4. Yeah? A lot of people stopped right there. Okay? And then they lost a point. A lot of people started to expand this. They still lost a point. Okay? Well, you could do that actually. You get there eventually, but it's just they got lost and then they gave up. You have to be able to recognize a special rule. What is the special rule that I'm itching to say? The difference of squares. You guys remember that rule, a squared minus b squared? Whenever you see something squared and something else squared and they're being subtracted, what is the rule? How do you factor those? A plus b times a minus b. That's a special rule. Okay? You have to be able to recognize that. For example, if I have x minus 9, x squared minus 9, what is that? That's really x squared minus 3 squared, huh? So that's going to be x plus 3 times x minus 3. You all with me?
Yeah.
That's called the, you need to write that down somewhere or tattoo it to your forehead or something. Difference of squares. Okay? And then you look at a mirror and read backwards. Okay? Alright? Do you guys recognize that this is a difference of squares?
Yeah.
Because this is x plus 1 squared. But 4, is that a square? Yeah, it's 2 squared. So instead of 4, can I rewrite that as x plus 1 squared minus 2 squared? Okay, so what's wrong with what I did so far? Any mistake that I made? Left them all behind. So many people, they just so focused on what they're doing, they just dropped it. Don't drop that. Okay? Nobody got that. Alright. So don't drop it, guys. So what can I do with this difference of squares? This plus this, right?
And then minus.
Times that minus that. You see that? Okay. Now I'm almost there. Don't drop that. Okay, what is x plus 1 plus 2? Hey, am I allowed to just combine them like that? Is that allowed? Do I have to distribute?
Yeah. Well, you know, you combine those.
Why don't I distribute?
Because there's a plus.
There's a plus there. So remember associative property, if it's x plus 1 and then plus 2, can't I just do the 1 plus 2 first?
Yep.
And then what's 1 minus 2?
1. -1.
So there we are. Or you could even be you could even say this if you want to be fancy. Not even, this is not fancy. This is not fancy, but extra. If you want to be extra, you can say that, but really this is good enough. Okay? Or that's good. Okay? You guys see that? Okay. So I'm going to give you guys a little bit of work time now, okay? I gave you guys 3 worksheets. Okay? I want to point out a few things. Can I see the 3 worksheets that I gave you guys? Somebody hand me? Okay, thank you, Azteca. Thank you. Oh, you're so. Oh, wait. Yeah. Okay. So. Okay, so it looked like everybody was cool with level 1, right? But level 2 is like the one where you need the box method or the factoring by grouping, the split the middle. So you guys could try those if you want practice on those. If you feel like those are too easy for you, go ahead to the level 3, or no, go to the level 2.5, which is this one. This one starts off with the easy ones, right? But then it has some weird ones like this. It has some difference of squares. Oh yeah, these are the kind of tricky ones. So you should try level 2.5. Is this one, all of these guys. Ooh, and these are difference of cubes. So we haven't even gone there yet, even though last time we learned it. Okay. And then, okay, this is level 2.5. Oh, you guys, please, please, look at that. Difference of squares, sum of cubes, difference of cubes, special products. Remember this is what I was telling you for? These you should, remember you're like, how come nobody ever taught us this? You should know that a plus b squared is a squared plus 2ab plus b squared. Okay, you should know these. This, no, because this is all algebra 1 stuff, okay? And the cubes is algebra 2, okay? Yes, yes. Well, if you could do the box, but these, like, you should just be able to recognize them. And then, if you feel like you're confident on that, then go ahead and skip to this one. This is the level 3 stuff. Okay, in fact, guess what? Does that look familiar? That's why I put this on Schoology, and every question on your test was from Schoology, or mostly. Okay? But people aren't that thorough, so even if I let you have that test answers, you still get surprised. I don't know. Okay, so you guys choose whichever worksheet you feel like you're appropriately should work on. I will check in with my calculus people and then come back to you guys, okay? Help each other, okay?
I have to go.
Okay. And then I'll try to have little check-ins with you.